Okay, this is 7th grade lesson 5.2. The objective students will use stated relationships to solve problems about perimeter and area of similar figures. The standard covered in this lesson is 7G1. The page numbers out of the hardcover book is pages 200 through 205, and out of the practice journal, pages 111 through 114. Yesterday in our activity, we worked with similar figures and understanding that when we have similar figures, their areas and perimeters are similar, but they're not always doubled or tripled. It's just they are similar to each other. Okay, so today we're going to be working with similar figures, and we have to understand that two figures that are similar then also have perimeters that are equal to the ratio of their corresponding side lengths. So for example here, what this whole thing is stating up above is that if I know that these are similar, these two side lengths are also proportional, which means the entire perimeter of this figure follows that same proportion, okay? Yesterday, when we worked with the little squares and we had 1 by 1 by 1 by 1, when we doubled that or took that times 2, okay, each of our sides then became times 2. Remember, 1 times 2, we had 2 sides here, and then we had 2 high and 2 across the top. So everything was doubled. Okay, that's a proportional relationship. We know that this one length right here is the same as this two-sided length there. In proportion, they are the same. Okay, because those are similar figures. So that's what we're going to be working with today. It says find the ratio of red to blue of the perimeters of these similar rectangles. So they are telling us they are similar, which means they are proportional. They've only given us one side length, and they have asked us to state it as red to blue. So we're used to having 2 sides on each figure, or 2 sides on one and 1 side on the other. This time they're only giving us 1 side length of each and asking us to share the ratio of the perimeters. Well, we don't have to know this other length here. We know that this 4 is proportional to this 6. So we're going to go ahead and just set those two numbers up as a proportion or a ratio, a fraction. Key thing is to make sure that we put them in the order stated. So they stated red first, so that was our 4 side, to blue, which was our 6 number. Now remember, those are the same sides, which means they are proportional to each other. Our final step would be to go ahead and reduce this. So our red is actually 2/3 the size of our blue. Our perimeter is 2/3 the size. The red is 2/3 the size of the blue's perimeter, or the side length of 4 is 2/3 the side of the 6 on the blue. Okay, this is our final answer, stating our ratio or our proportion, okay, in reduced form. Key thing is making sure that you reduce them down. Okay, so let's go ahead and try another one. Making sure that we are identifying the order that they are asked. Find the ratio of red to yellow of the perimeters of the figures. So keep in mind they asked red to yellow. So we have to do our red first. So our red was 14 to 4. Now, you guys before in previous lessons also did ratios as 14 to 4 or 14:4. The key thing is when we're doing this is we want to make sure that we reduce these down to lowest terms. So a number that would go into each of these would be 2. So I could divide by 2. So 14 divided by 2 would give me 7. And 4 divided by 2 would give me 2. Okay? So our red figure is 7/2 the size of the yellow, or 3.5 times the size of yellow. Okay, this is my final answer. Now, that was because it was the way that it was asked. It was asked red to yellow. Had they asked yellow to red, well, then we would just flip that over. It'd be 2/7. But they asked red to yellow, so red was stated first. That has to go on the top of our ratio if we're setting it up as a fraction, or in the front if we set it up like this. Remember, all of these are interchangeable. This is the way our book is using them right now, is in the ratio of a fraction format, okay? But they are all interchangeable. So you have to be prepared to be able to identify in any format. Okay, so I want you guys to try this one. Find the ratio of purple to green of the perimeters of this figure. So go ahead and find the ratio of purple to green. you should have gotten 4/7, and that cannot be reduced down any more, so your final answer is 4/7. Okay, purple was stated first, so that's our top number. Okay, so that's working with perimeters. Now, the other thing is sometimes they ask us area figures. We're still going to follow the same concept, but there's one additional step. Remember when you do area, anytime you label it, you always have to do whatever it is squared. So for example, if I had this square here and it was 1/1, we would take 1 times 1, that would give us 1. The unit, we'll say, was centimeters squared. Okay, that is the only piece that we're going to go ahead and do, but we have to make sure that we first reduce our ratio and then square. Okay, so it says if two figures are similar, then the ratio of their area is equal to the square of the ratio of their corresponding side lengths. So it's the same thing that we just did, but now we're going to square that because area is squared, perimeter is not. Okay, so here we've got our original here of it asked us to do red to blue. So originally it would be 6 to 10. Okay, key thing is we must reduce first. So if I reduce this down, I see that 2 would go into each of those. So if I divide by 2/2, that gives me my final ratio of 3/5. Now that's if it was perimeter. Well, now they're asking for the area. So we're going to go ahead and we're going to square this. Okay, 3/5 squared, that sounds really confusing, right? Well, here's another way of looking at it. We're going to do 3 squared over 5 squared. If you're more comfortable seeing it that way, then go ahead and work off of like that. So 3 squared would be 9. 5 squared would be 25. This is our final answer. Okay, so the area of red is 9/25 the area of the blue, is basically what we're saying. Okay, so we still follow those same steps, setting up our proportion in the order stated, reducing it down, and then in this situation, we're going to go ahead and have to square that. Okay, so let's try another one. Okay, find the ratio of red to blue areas of the figure. So red was 4, to blue was 6. So now we need to reduce that down. When we reduce it down, it becomes 2/3. Now it was asking area. So we have to square this. Okay, so it's the same as 2 squared over 3 squared, which would give us 4/9. Final answer. Red is 4/9 the size of the blue for the area. 4/9 the area of the blue. Okay, so I want you guys to go ahead and try this one. Find the ratio of purple to green of the areas of the figure. So remember, it's asking areas, so there's that one extra step. So go ahead, pause your video really quick and work your way through this one. So your final answer you should have gotten was purple to green. Well, purple's area was 16/49 of the green area. Okay, so that's where they give us figures. They're giving us some pictures. Sometimes they're going to give us words. Okay, and if you are somebody like me, the words, I sometimes have to draw just a brief picture. Okay, it says the base of a triangle P is 8 meters. So it doesn't matter the shape of the triangle, it's a triangle. So we'll just do this. So the base, this is my base, is 8 meters. Okay, and this was triangle P, not that I have to label that. It says the base of a similar triangle Q is 7 meters. So we have another triangle that looks similar to this. Okay, so I'm just going to copy this so that it's actually is similar. But I'm going to shrink this one down a little bit. And instead of this being 8, it's a 7. And this was triangle Q. Okay, so if you need the picture, you can use the picture. Some of you won't need it. Some of you will be able to read that and not need the picture. So it says, what is the ratio of the area of P to the area of Q? So we're doing area. P was 7. No, sorry. P was 8. To Q was 7. And it's asking area. So we're going to square it. Okay, so 8 squared is 64. 7 squared is 49. Final answer. Okay, so my final answer is that P is 64/49, the area of Q. Okay, remember, when you're doing area, you have to remember to square that ratio once it's reduced, and in this case, it was reduced. Okay, so I'm going to go ahead and give you one of those. Actually, maybe we'll do this one together. Okay, so it says you place a picture on a page of a photo album. The page and the picture are similar rectangles. So that means they're proportional. How many times greater is the area of the page than the area of the picture? So once again, we're going to do what we were just doing. They're just wording it differently. So the area, well, they're asking that how much greater is the area of the page than the picture. So the page was 8 to the picture was 6. So we want to reduce that because both of those are even numbers. So we'll divide by 2, which would be 4 to 3. Okay, now it's asking area. So we're going to square it, which would give us 4 squared is 16 over 3 squared is 9. So the area of the page is 16/9 the area of the picture. It says the area of the picture is 45 square inches. What is the area of the page? So the picture is 45 square inches. What's the area of the page? So let's go ahead and do a proportion with that 45. So I'm going to take my original 16/9, okay? And we're going to set it up as a proportion. So let's see, the picture, remember the picture was my bottom number, my second number stated. So picture was 45. How could we solve for X? Cross multiply divide, right? So this is something, and this one's kind of a tricky one. It's kind of an advanced thing. So 45 times 16. Now we're going to divide that by 9. It gives me 80. So then that would be inches squared or square inches. Okay, so that's just advancing it. That's one of those higher end questions, advancing it out a little bit. Okay, so I'm going to give you one. I'm just going to jot down maybe a picture, and I want you to try it on your own. Okay, so I've got these two, rectangles, and we'll go ahead and change the color of one of them. Okay, and dimensions, let's do, this one is 8 and this one is 5. Okay, so what I would like you to do is I would like you to find the ratio of the perimeter. So do perimeter and the ratio of the area. And let's do blue to yellow. Okay, so I'd like you to find the ratio of the perimeter and the area, blue to yellow. Okay, so for the perimeter, you should have had 5 to 8 because that was the ratio, 5 to 8. The area had to then be squared. You had to square your perimeter. So you ended up with 25 to 64. Okay, key thing to remember out of this lesson, your ratios, pay attention to the order that they're being asked. When you go to do area, make sure you reduce first and then square.